Good day to you, students. Welcome back to class. I want to appreciate those that are commenting and those that are sending their classworks online. Thank you so much. It's a wonderful one. I want to beg you to keep growing. Don't stop doing it. Just continue. And as let's move on to the theorem 8. So far so good. We have talked about 7 theorems so far. One that has to do with a chord and a radius, which is the first theorem. Another one that has to do with chord and a radius in an angle. The first one is on site, but the other one having a relationship with the angle, that is angle at the center twice angle at the circumference. It goes to angle in the same segment, which could be chord and a radii or 2 chords. Then we moved to angle in a semicircle. That means it's a relationship between chord and a diameter. We move to cyclic quadrilateral, where we have 4 vertices of the quadrilateral at the circumference. Then from there we moved to a relationship between tangent and a radius. A tangent and a radius that will give you 90 degrees when they meet at the tangent point. Then from there we move to relationship between a radii then with 2 tangents. Now today we want to move to the relationship between a tangent and a chord. A tangent and a chord. So let's see how it goes. Theorem 8 says we call it alternate segment. What do I mean by that? Pay attention. The angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment. Please let me take it again. The angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment. What does this mean? The angle between the the angle between the tangent and the chord, this angle, there's another tangent and a chord, so they are referring to these angles. This is a tangent and a chord, this is a tangent and a chord. What happened to them is equal to the angle subtended by the chord in the alternate segment. So if you have, this is the angle, the chord we are talking about, the alternate side of it. So this angle is equal to this angle. That is what they are trying to say. Interesting, right? So this one, once we pick this one, this is a connecting chord, so it means this one is what they are referring to. If this one is X, definitely this one will be X. If this one is Y, definitely this one will be Y as well. That is what the theorem is saying. They call it alternate segment. So I told my students that, okay, this is how it goes. If you see a triangle inside a chord connected to that tangent, you will definitely see alternate segment there. That's what I said. Let me take it again. If you see a triangle inside a circle that is connected to tangents, look at this, that has either connection to the tangent, either here, the tangent is here, or the tangent is here, that is connected to the tangent, there is always an alternate segment. There is always an alternate segment there. Always, please. When I say always, I mean all the time. So how do we read it? So I told them that when you have this, you leave this angle, then you go to this. When you have this, you leave this angle, then you go to this. So here will be equal to this, this will be equal to this, and this will definitely be equal to this. That is what we call alternate segment. Let's check a few examples of how this can be used, then we can then proceed. Yes, let's check this question up. Alright, let's pay attention to this question. We have our tangent, the point of tangency, and like I said, I just noticed that there is a triangle. There is a triangle that is connected to my tangent, so I am sure there is an alternate segment there. Then the question is, which one will be equal to which one? Which one is equal to which? So let's check now. I have a feeling to get my x according to the question, I have 2 options. Interesting. So I am sure this angle, because it's connected to this chord, then leaving this one, it will be equal to this. So I am sure this one is 65. Don't forget, this is my pencil. I am sure this one is 65. So angle on a straight line will give me x because it's equal to 180 degrees. Or better put, I have this one that is connected to this, so I know this one will be 55 by alternate segments. So if that is the case, I can use sum of angle in a triangle to get my x. So the game is over. So how do we go by this? All I need to say, okay, if I use 65 here, all I have to say is ATX, that means ATX, this angle will be equal to 65. Why? Alternate segments. Alternate segments. So once we have alternate segments here, then we have obviously this one is 65. Therefore, 65 plus x plus 55 will be equal to 180. Why? Straight line. Straight line. So if that is the case, then we'll add this one to this one, and we add this one to this one. That is going to be 120. This is 5 plus 5, 0. Then this and this, that is 11 plus 1, that is 12, plus x is equal to 180. So my x is equal to 180 minus 120. Then my x is equal to 60 degrees. That is how I get my x. And that is all about the question. This come a lot in objective questions, WAEC, NECO, JAMB, something like this. All you need to do is to link them together. You get your answer, then you leave the question for another without wasting time. So let me check another example. Then I'm sure you can understand this one, so we can move to another example. Let's check this question. Let's check this question out. We have a as our point of tangency that goes to P. Then we have A to D, we have A to B as well, then we have A to C. So here as you can see, we have a triangle, then another triangle. Definitely we have a series of alternate segments there. We have PAD, that is what we are asked to find. PAD, that means this point, that is our x. That's x. We have to find x here. So how do we go about this? Don't forget your pencil. Let us check this out. Then we know how to write it for WAEC. So here I know that this line, this angle, sorry, will be equal to 1, 2, 3. That means a triangle. That means leaving this one to this point. This is 70 degrees. Alternate segments. Then once I have alternate segment and I know good that this angle is equal to this angle, do you remember? Same segment? Good. So if this is equal to 70 and this is equal to 70, then this AB is equal to BD according to the instruction given to us. Look at the sign. I have drawn it before now, so you should have noticed that. So from there, we have this one equal to this one, and don't forget that the base angles of an isosceles triangle are equal. So this one is 70. Definitely this one will be 70 degrees. So if this one is 70, then 70 and 70 and x will give you 180 degrees. So we know our x is 40. Then we tick 40 in an objective. But if it is theory, this is how we go about it. Then we say, let me call this one Q now. So I will have our QAB. That means QAB is equal to 70 degrees. Why? Alternate segment. So if this one is 70 degrees, then we have ADB too. So ADB as well will be equal to 70 as well. It could be, apart from the fact that they are alternate segments, apart from the fact that they are same segment, this angle using this triangle is as well equal to this angle, because we go this way, come this way. So we have 70 as well. So alternate segment is proved very correctly. So We have this one is 70. Either I use same segment or I use either I use same segment or I use alternate segments. So this one is alternate segment or same segment. Let me put same segment there. I like the fact that it's a different segment to the other one we have used. Therefore, 70 plus 70, or before that I can say QAB plus ABD, or ABD. But before that, before that one we have this one. Before that, we have not talked about this. We only talked about it in the analysis. Let's talk about this. So this one, AB, don't forget AB is equal to DB or BD. This has been given isosceles, or you write given there, it has been given. So we are so much sure that BAD is equal to 70 degrees isosceles. Triangle. Isosceles, let me write my triangle very well. Isosceles triangle. Isosceles triangle. So from here we can have 70 plus 70 plus x. Therefore we have 70 plus x is equal to 180. We know that, right? Straight line. So we have 140 plus x is equal to 180. So our x is equal to 180 minus 140. So my x is equal to 40 degrees. Then you have your full mark for WAEC and NECO. But don't forget, we have already gotten our mark since, and we have left for another question in your JAMB. Let me give you classwork to do. Let me see if you can locate your alternate segment. And if you can't, relax. It is mathematics. You are not in bondage. If you cannot, relax. Just let me know you are finding it difficult to look into or to see. Then I will communicate it again with you. So it may now be personal, but I will definitely do that. Don't forget, the aim behind this is to grow together in mathematics. I really want you to grow. The objective is to eradicate fear for mathematics. Number one is to erase examination malpractices, and as well as to eradicate completely mathematics failure. It's becoming too much, whereby you have you would hear people failing mathematics, this simple subject. Why would you fail it then? That is the reason why we have come online. You have your phones with you, you have your systems with you, then you can learn online too. And you know, pandemic has spoiled a lot of things, so you really need to develop yourself online. So if you have not subscribed, please do. I need to address this as well. A lot of students would come to me and say they don't know subscription is free. They don't know it is free. It is free, my dear. Subscription is free. It doesn't cost you one dime. All you need to do is to click that button. Just click the subscription button, and there's a bell by its side. That is notification button. What that one does is, when every time a video is posted, you will see it immediately. You will be able to know that there is a video posted. That is just what that does. It is called the notification button, to notify you that there is a video that is posted for you to see. These are your classworks. From number one, don't forget you have to find the marked letters. This is Q. There is X here, there is Y here, there is Z here, there is X here, there is X here, and there is Y here. So let us see. This is not the theorem that I gave to you now. It is the theorem in the last question. In the last theorem, it is a question from the last theorem that talks about tangent and radii, you remember, and two tangents connected outside the circle. So you should be able to do this one. It's simple, right? There are a lot of things that are very interesting here. So, and here we have a diameter There's a law on the diameter. Don't forget there is a theorem on the diameter. So we have x, we have a y, we have a z. So you should be able to fix this one. So, and there is this thing that means this side is equal to this side. So please note that. So here too, then we have another one that is equal here. We have this angle to be 44, we have this to be y, then we have this to be 50 degrees. We are solving this to be 50 degrees. We are looking for x and y. Looking at this, we have a tangent that is connected to a triangle, and also we have a cyclic quadrilateral here. So we have everything we need. The theorems has given us help enough to be able to tackle these questions. Please, once you finish up, send it to my WhatsApp page, then we can discuss if you are right.